Okay, so we are solving the problem 3160. Find the number of distinct colors among the balls. So you're given an integer limit and a 2D array called queries of the size n times 2. There are limit plus 1 balls with distinct labels in the range 0 to limit. Initially, all balls are uncolored. For every query that is in the form of x comma y, you mark the ball x with the color y. After each query, you need to find the number of distinct colors among the balls. So a pretty straightforward problem. At least the idea is kind of straightforward that uh, you are given a number of uncolored balls, and after each query, some of the balls will be having a different color. So you have to find the distinct number of colors after each query. So initially, if you think about this problem, this like you might think along the lines of having a hash map or a dictionary, and then for each query you can go through the entire dictionary and find uh, basically the number of distinct colors. But that is the root 4 solution, but that would be O of n square solution. And like looking at the problem, you can get the intuition that you need a faster solution. And if you check the constraints as well, uh, they have n going till 10 to the power 5, which is a giveaway that you need a faster solution. And most probably you need an O of n solution. So after a bit of I think it can be pretty obvious what you need to do. So you can look at the examples and get the intuition that uh, you need to maintain some kind of dictionary that tracks what kind of basically what kind of labels have you seen before, so that you can track that. Okay, so I've seen in the first example, so I've seen one before. So if you go to this test case, this index, you will know that you okay, so I've seen one before, and I'm changing the color of one, so the number of distinct colors do not change in that way. So the solution is along those similar lines, and I will explain more as I write the code. So first of all, you have n is equal to limit plus 1. So n are the number of elements. Let's maintain a result array, and at the end we'll return that result. So for each query, we have x comma y in queries, and so we need to have a few other dictionaries. So first will be let's say, have you seen labels? So this would be a set to store what kind of labels have you seen earlier. Then we can we can create a general color map that maps the label to the color. So it can be a default dictionary of the type in, and we can also create a color count. So that would be helpful to get the final count of the distinct colors. This can also be a default dictionary of the type in, and yeah. So let's say we want to handle the case where you have seen a label before. So if x in scene labels. So if it's in the scene labels, the distinct count is not going to change, but you have to change the color count dictionary. So you have to decrement it. So we'll get the previous color of the label x from colors dictionary, and so the new label, that is y, we can just increment it. So color color count of x, sorry, color count of y plus equal to 1, and now we have to decrement the previous color count. So color count of previous color is equal to, it's a max of 0 comma color count of previous color minus 1. This ensures that we don't go into, like, we don't go below 0. And if color count of previous color is equal to 0, we just remove it. And this is important because we have to find the distinct number of colors, and you cannot have count is you cannot have colors in your dictionary having count zeros, because that would technically count as a distinct color in our calculations. So we'll do this, and if not, if it's a new label, we so in both cases we have to assign x to be equal to y, so we can take that out of the if else. And if x is not seen, we can just add x to the seen labels, and we can increment its count. So increment the count of y by 1. And after each query, you have to add it to the result.append. So we are going to append the distinct number of colors that can be found by length of color count dot keys. Should be good enough. Let's check. So colors is not defined. It should be color, and okay, okay. Let's give it a submit. Okay, there you go. So this is a pretty optimal of n solution, and yeah, should be O of n. Yeah. The top solutions have a similar idea. So they just take, like, they take in an array instead of a set, which I guess is more efficient, but this works as well. All right, see you tomorrow.